Sample problem 14.3 is very similar to the precipitation reactions we were doing earlier in Chapter 4 when we were writing those balanced equations, ionic equations and net ionic equations. We can do the same thing with acids and bases because those things will dissociate, right? A strong acid will dissociate completely to form ions. So let's see. A part says it wants us to write a balanced molecular total ionic and net ionic equation for the following acid-base reactions and identify the spectator ions. So A part says that we have hydrochloric acid. Remember, that's HCl. Now, if you're confused on some of these acids and their formulas, remember, look in table 4.2 on page 159. AQ plus potassium hydroxide, KOH, right? Potassium hydroxide, and that's AQ. So that's my base, and that's going to yield. Now, this is going to be very similar to those precipitation reactions where we had the cation pairing with the anion of one and the other, vice versa, right? So the thing that has the positive charge in hydrochloric acid would be the proton, right, the H+. The negative thing would be the OH. And what happens when I pair H and OH together? That's H2O, right, water. So H2O, all right, and water is a liquid, plus, let's see here, I have a Cl and the potassium, right? So potassium has a plus charge to Cl, so that's going to be potassium chloride. So plus KCl, and remember chlorides are soluble, so are group 1 metals. So this would be AQ. All right, now is this balanced? Let's see. I have two hydrogens. I have two hydrogens. I have one chlorine, one potassium, one oxygen. So it's already balanced, so that's good. So the next step is to write the total ionic equation. So I'm going to check the solubility rules. Well, I'm going to have to do a number of things, right? First of all, I've got to determine, is hydrochloric acid a strong acid? And yes, in fact, it is. So that means it's going to break apart into ions. So I'm going to have H pluses in solution plus Cl minuses floating around in my hydrochloric acid bottle, right? I'm not going to have HCl's floating around. I'm going to have protons, H pluses, and Cl minuses. They're not going to be bound to each other. Plus potassium hydroxide, potassium, group 1 metal, all of them are soluble, no exceptions, so plus K plus AQ, plus my hydroxide ion, OH minus AQ. All right, and so there's all of my reactants, yields. Now I got to do my products. So let's see here. I have got H2O liquid. I mean, that's water, right? It's not going to break apart because it's water. So I'm going to leave that together. Plus KCl, that's going to be AQ. I knew that because I checked the solubility rules, and group 1 metals are all soluble. So K plus AQ plus Cl minus AQ. All right, so that would be my total ionic. Next step, we got to write the net ionic and identify the spectator ions. So the spectator ions are the things that appear on both sides in the same form. So write my Cl minus. That's on both sides of my yield arrow in the same form. My potassiums, that's on both sides. So there are my two spectator ions. To write my net ionic, I bring down everything that's not a spectator. So H plus AQ plus OH minus, that's not a spectator. I didn't have it on both sides. Yields H2O liquid. All right, so there it is. I've got my balanced equation. I've got my total ionic equation here. I've got my net ionic, and I've identified my spectators. Those red boxes, right? Those are my spectator ions. And then we have to do the same thing for B and C. I'm going to stop there and let you guys practice those on your own. And if you have any questions, you can send me an email about it. But check your solubility rules, check whether things are strong or weak acids, and that'll tell you if they're going to break apart or not, okay?